This video is on atomic structure. After the structure of the atom was deduced from the Rutherford lab experiment in 1909, it was not until 1932 when the neutron was discovered, and so a more complete structure of the nucleus was formed. So now we have the following picture of the atom with a small central nucleus of protons and neutrons and orbiting outer electrons, with the only difference that the orbiting electrons are only allowed to be in specific orbits around the nucleus, as we just saw in the animation at the start of the video. This now gives us the current model of the atom. The nucleus is in the center, composed of positively charged protons and neutral, no charge neutrons. We can see orbiting negatively charged electrons around the nucleus in specific orbits. We can draw a table to compare the mass and charges of these three particles to each other. Take the mass of a proton to be 1 and the charge of a proton to be +1, positive charge. Neutron will have a mass of 1, as it is almost the same size as a proton, and a charge of 0. Electron will have a mass of 1/2000, as it is much less massive than a proton or a neutron, and a charge of -1, equal and opposite to the charge of a proton. Moving on to atomic number and mass number, we can represent a nucleus using the following notation. Z is atomic number, and this represents the number of protons in the nucleus. A is mass number, and this represents the number of protons and neutrons in the nucleus. X is the symbol for the element, and so for lithium it would be Li. Please be aware that the atoms of the same element would have the same atomic number, but could have different mass numbers. Isotopes. These are atoms of the same element with the same atomic number, protons, but different mass number, and hence they have different numbers of neutrons. Let's look at two isotopes of helium now. This is helium-4, which has 2 protons and 2 neutrons here. Now this is helium-3, but this time we only have 1 neutron. Now let's look at ions. These are atoms that have a net charge, usually the loss of an electron, and so a positive charge, as they have more protons than electrons. This diagram shows a helium atom with a single electron orbiting, so it has a net positive charge as there are 2 protons and 1 electron. We will finish off this video by going over some worked out example questions. This is example question number 1. The following atom is written by the shown notation. We need to state the number of neutrons in the nucleus. Well, we know the number of protons is 82, Z number, and the total number of nucleons, protons and neutrons, is 207, which is the A number. To work out the number of neutrons, we just need to take away 82 from 207, which is 125. Moving on to example question number 2. We need to state the number of electrons if this atom is not an ion. In this case, since the atom has no net charge, it must have the same number of electrons and protons. As we know, it has 82 protons, number on bottom left of symbol for element, then it must also have 82 electrons. A final example question. Looking at the 2 atoms below, we need to work out, are they of the same element? Yes, as they both contain 6 protons, Z number or atomic number, they are in fact both isotopes of carbon. Thank you very much for watching this video.